So thanks everyone for coming. I really appreciate you choosing to come see my talk. I know there's a lot of good things to see. I work for a company called Gradle Analytics. I'm actually one of the owners. We're about 25 people. We have offices in Atlanta and Minneapolis. It is a matrix reference. I'm sure you probably got that. But we do sort of use subtle hints of it in our marketing, in that we do want to change BI delivery with continuous integration and automation. That's on our business cards. So that's what we do, and that's why I'm here. So this is called Use Gradle to Build and Test Anything. So what I'm going to use as, we've built a product called Checkmate, and this is what we're going to talk about today. It's a Gradle plugin. It's a series of Gradle plugins, really. And so I'm going to talk about sort of our journey into automating a piece of enterprise software. So I don't want you to get too bogged down with what we're automating. I will have to talk about some of the APIs and some of the challenges. But I think you can use this as a model for other tasks, other chores that you want to automate. We do have, I know they were talking yesterday in the cloud services. Our plugins are cloud services enabled as well, and we're an analytics company. So immediately we started wanting to look into Gradle builds, Gradle tests, and failure rates. So this is our cloud services available now. And here's just a few screenshots of some of what you can expect. If any of this sounds interesting to you, let me know. We also bring in GitHub data through webhooks or GitHooks. So we blend commit data with Gradle data, which is interesting. We also bring in Jira data for those of you that use Jira. So we bring all that together in our cloud services. So Oracle Business Intelligence is a tool we work with quite extensively. I am what's called an Oracle ACE Director. That's Oracle's highest level of community advocate and expert. There's about 100 of us in the world, so for a company of Oracle size, I think that says something. So I know this product very well, but I don't want to focus on it, as I said. I want to talk about how you could use Gradle to automate and test almost anything. And so those of you that are build masters and Java shops or developers, what I would ask you to take away from this talk is there are other areas of your organization that are probably struggling with automating legacy, enterprise, thick stack products that might be able to, you might be able to help them automate some of this using Gradle. So it's just a thought. So think about, there's a similar partner to us that does this with Fusion middleware and Fusion apps. They don't use Gradle, but they use other things. So enterprise software is, difficult to manage, but Gradle has all the pieces necessary to literally automate almost anything. So I want to lay the groundwork a little bit about what's going on in the analytics space so you can see why this is important. So Gartner recently took BI Magic Quadrant and split it. This is they did this for 2016. The reason is they have completely given up on enterprise reporting, thick enterprise packages of reporting software, BI products, because they are so slow, okay? They are difficult to manage. So, but here's the thing. There are millions of dollars invested in these products, and it doesn't matter what Gartner thinks or even what the status should be. These things aren't going away anytime soon. So the important thing is, can we take these older systems, not older because they're innovated still, but their architectures are not architectures that are prone to be continuous in any way, shape, or form. So I want to talk about just a couple of things that makes these things different, so that we can hopefully set the stage. So building these robust models, robust reporting catalogs, that's for enterprise reporting. That's not really what happens in the analytics space. So the analytics space is a lot of newer technologies, a lot of big data technologies, frankly, a lot of things that are built with Gradle, quite frankly. And it's the idea of putting data in a lot of different places and really using it just in time. And that's the new world, and I'm not going to disparage that in any way. Okay, those are great things going on, and we do a lot of consulting in those areas as well. But your Fortune 100, Fortune 500 customers, they're trying to close the books every month with financial reporting. They're not going to big data anytime soon. And finally, what everyone here can sort of appreciate is, mostly configuration on this side. There's not any source code. There's not really any source code. We'll talk about what source is in these tools, at least in this one. But there's not really any source code. Nobody's in an IDE writing anything, okay? It's usually GUI tools, web-based reporting tools that have repositories and things that store that information. So it's not really source control, and there's no IDE. So if you think about how do I automate that, can I even use source control? And that's the challenge that we wanted to take on. So these are sort of our driving principles. We wanted to make specifically BI or Oracle BI act like a Java shop, okay? Use a continuous integration server, use source control, regression testing. No, none of these enterprise platforms have any concept of regression testing. That's why the QA cycles are so long. Nothing's automated, okay? So that's the challenge. Here's our driving principles. So one thing that really brings down enterprise reporting is we focus so much on the end state, or at least other companies do. So such that agile methodologies and delivering something this month is just not really on their radar. So as a process, we preach that as well. Let's focus on what you're gonna have next week or next month, as opposed to arguing for 3 months in the sales cycle about what it should look like a year from now. That's typically how data warehousing and BI projects go. It's maddening. We want to use these, automate things. Just like all of you are so used to. You may change jobs, you walk in and you just say, where's the automated processes? What do you guys use? We're in areas where no one automates anything, okay? So we truly are sort of sticking out in the crowd in that way. So if you want to really embrace change in the space, these are the things that none of these customers do. They have content that they require for legal purposes to close the books, and none of it's in source control, okay? So I just want to set the stage on where we're at with a lot of these customers when we go in, okay? And so really, you guys have probably seen this slide. It's from Spotify. But anyway, what enterprise reporting tends to be is thinking about the car, the entire journey, when really you should just incrementally add some things, get value, etc. So I want to talk a little bit about our journey to Gradle, really, okay? How we got there. So when we started out, there's a lot of APIs, and I've in Oracle Business Intelligence, and I've got a slide that kind of shows you all the different APIs. So what we initially, anytime we go into a customer, they're shell scripting this stuff, right? And we've done that in the past. So we started thinking about where are we going to put this logic such that it's repeatable. So immediately we started thinking we're going to do CI, so we'll write a Jenkins plugin. And we got pretty far down the road before we hit our first non-Jenkins customer. I mean, who didn't see that coming, right? So then we started thinking about, well, let's write this up in jar files that we can call from anywhere, right? So we started writing this in Groovy. We had just used Groovy in the Jenkins plugin. Groovy is used in several Oracle products as a scripting language, so most of us knew it. So it made a lot of sense. But then as we started building that product, we chose Gradle, okay? And immediately we saw that this is where our product should be. It should be a series of Gradle plugins, okay? By the way, I'll take questions anytime. Happy to do that. So our main plugin configuration looks kind of like this. And I'll talk about why we have these 3 configurations in a minute. But we publish content. When we build this content, we publish it. And for different areas of regression testing and releases, we may want to pull down prior versions of the content. I'll talk about why we do that in a minute. But we use Maven for that. We use S3 most of the time, the Maven plugin to S3. which I believe was 2.11 when that was introduced. And then we're able to define with a closure one or more regression testing libraries. So in this huge web catalog of reporting content, we're able to identify areas of the folder that we want to be the regression tests, okay? So we'll talk through how it works in a minute, but we actually upload the old content, run the tests, patch the content, run the tests, compare the results. We do that automated every time someone publishes a build, so that you make sure your reporting numbers don't change. I mean, it's so obvious, but that's what 90% of the QA process is about in enterprise reporting. And that's one of the things. I've got some code samples to show you how we do that. And then obviously this is for our analytics. You can enable one or more streams. We just stream the data to AWS, big surprise. And then we have to tell Gradle where our APIs are, where we use a lot of command line utilities. We have to tell them where to go find those, okay? So these are our two plugins. We actually have a couple more in development, but we have sort of a core plugin we call Checkmate. This works for any Gradle build. It's not specific to our OBI plugin. And this is what enables that analytics, those screens you saw. Some basic configuration stuff. And we do a lot of this with build, task, and test listeners. Okay, so the analytics is just a test listener that streams data to the cloud, or a task listener, or a build listener. Then when you look at our OBI plugin, that's more of the OBI functionality. Oracle Business Intelligence, sorry, got to get used to my audience. OBI functionality. And also we have some specific analytics that we stream particular to that product. Okay, information about what's going on in those, what content has changed, which reports, which columns, etc. And then when you enable the OBI plugin, which enables the Checkmate plugin, we get a whole bunch of tasks specific to doing your work in Oracle Business Intelligence. So I'm going to bore you for a minute a little bit about the architecture just to show you the challenges, okay? So Oracle is, in its very nature, an acquisition-heavy company, right? We all know that. So they focus a lot on the end user, the smoothness for the end user, so it doesn't look like they've patched together a bunch of products, which in a lot of cases is exactly what they've done, okay? So these are the APIs that you would have to script in any, forget about an automated or continuous environment, just to do deployments, etc. Okay? So for those of you that don't know, WebLogic scripting tool, maybe you've worked with it, it's Jython. It's Python you actually use Jython, so it's easy to call Java classes. So it's a scripting language in Python that allows you to easily call Java classes. Okay? So these are all of the things. We have what's called the presentation server. We have a lot of APIs for interacting with that. By the way, some of this is overlapping. You've got older and newer APIs, so you don't have to necessarily use all of them. But these are the ways that we typically deal with this. This is just to get some dashboards in front of you. I mean, when you look at it, it's sort of crazy, really. But this is the hand that was dealt to us. So why was Gradle so much more effective? Well, as I said, a lot of people were shell scripting this, but you want to run on multiple environments, so automatically you start thinking about something Java-ish, right? Or at least something not shell or bash. I don't know where I think I got this from Wikipedia. I was trying to go find where I actually got it, because some of this deck's about a year old. But I really liked this quote, which is it's not just about building software anymore. You can automate literally anything. If it has an API, you can automate it. And if it has an API, Gradle can automate it in most cases. So these are all the different reasons why, and some of this, CI handles this one, the CI server handles this one, obviously. But Gradle works in all your CI servers, so great. But these are all the different things that make just a workflow. Forget about if it's software, it's a workflow. makes this an optimal choice for automation. Dependencies. Imagine trying to write dependencies into some sort of shell or Java or whatever, right? How easy is it to do a depends on and a must run after, right? I mean, that is so simple, but it doesn't exist in any language or class that I know of. File operations, my goodness, the sync, copy, zip, all that stuff, using huge globs of file, include, excludes. Try to write that in shell, it's pretty difficult. The plugin architecture allowed us to write plugins to an infrastructure. DSL, obviously, publishing. So we build all these artifacts, we'll talk about what some of those are, and we zip them up. And Gradle doesn't care if it's a zip or a jar, just publish it. Write it to Maven, pull it from Maven. So easy. So you go to deploy to a downstream environment, we see a lot of people who are doing similar things that will go and check out source code repositories with artifacts in it because they don't know a good way to get things around, because they simply don't know that Maven is out there because they don't write Java. Okay? So this is one of the reasons why I want you to think about, can you help extend Gradle to other areas of your business? Because if you're a small startup and you're just writing software, I get it. But if you work for a big company, I guarantee there are areas that you could help innovate. And what we find with a lot of our customers, they don't know what any of this means because we're talking to the BI shops. And as soon as we start getting up the chain to talking about implementing, we come to find out that most of them have DevOps shops that have been on them for years to try to do something better. And they're using these tools. They're using Gradle, they're using Jenkins, they're using things like that. Okay? So I'll kind of fly through this a little bit, but you know, these are just expanding on that previous slide. So I want to talk a little bit about our build process. So I talked about, and I'm being very generic here. There's a lot of different, what I call source code. There's a lot of different sort of repositories that make this product go. But in general, the process is kind of the same. So this content, a lot of the time sits in XML files, okay? Some of it sits in binary files, but there are ways to, for almost all of it, move it back and forth between binary and XML. So we'll take the XML and we'll use that as our source control, okay? So nobody's hacking XML files, but they're using the built-in development tools, and we're putting it, and Gradle handles this, we're putting it, and I'll talk about that in a little bit, we're putting it in a source control. So we can automate that, which probably scares most of you to have an automated commit. But when we're able to properly educate, we usually take that out and have them commit manually, as you might imagine. But we do have some customers that I don't want to have to commit, I don't want to have to whatever. So we'll show you how we sort of automate that in a bit on the workstation itself. So we take source code, we check it out using a CI server, as you would imagine. We call a lot of command line utilities to build our binaries that we need. So these are not binaries that you're probably thinking about, jars. These are proprietary binary formats that a lot of the elements of the tool use. And then we also build incremental patch files. I'll talk about that in a minute. Those are for deployment and testing. Zip all that up and publish it. And the reason we do that is to make it easy to promote to downstream environment. That's why you saw the promote configuration. What version do we currently want to be promoting? You can put that in your build script. It pulls down whatever version you want to promote. We also had what was called release and feature. And those are two configurations you can use for testing. So if you want to test against the last release, whatever's in production, we can pull that content down to compare it with the current content. If you're on a feature branch and you're building just your stuff, we can set a configuration to pull down whatever the most recent thing that got published is. So you're testing just your changes. Does that make sense? Hopefully? So when so we're just going to drill in a little bit. When we build our artifacts, we convert it to a binary. So this is what we call our current binary. But then for reasons that hopefully will be clear later, we need a previous version. I just explained the multiple configurations or ways that you can test. So we go get that from Maven. We actually pull down a zip file of a bunch of stuff, and it's in there. And that's using just basic configurations and Gradle repositories and versions and dependencies. Nothing special there. But it's not pulling a jar, it's pulling a zip file, and we unzip it. We want to build incremental patches. So we don't want to move these whole big things into servers. Sometimes they have environment-specific information in them, which is just crazy. Sometimes it takes longer to deploy the whole thing than it does to deploy the patch. So this is one reason we pull down the previous version, because most of the command line utilities need the previous and the current version of the binary to build the patch files. This gets zipped up in our distribution file, as we call it. And it's for testing and deployments. We'll talk about testing in a minute, okay? Because we're not just simply writing a bunch of specs. We use Spock, and I'll talk about that too. But you can't just write specs and say, I expect this, I expect this. What you want to do is, I expect these numbers to be the same as they were before. So how do you do that? How in the world do you do that? You pull down a previous version of content, you load it into the build server, which is an OBI environment, you run a bunch of tests, you patch it, you apply the patch files, run it again, compare the results. That's what we need to do. That's what we need to automate. Does that make sense? So we build these patch files and put them in this distribution file so that when you pull it down from Maven, you have everything you need to test, to deploy, whatever, okay? Now these patch files can be deployed, these patch files are built just using the exec. And when you think about just how easy the exec is, how much code would you have to write to get -- info, to get all of that sort of information in your own scripting language, right? And have it automatically work with a logger and automatically, have whatever logging framework you want to use in your custom code automatically flow through to your build automation tool. I mean, that's really special. So deployments, either one of these we can deploy, right? I talked about the pros and cons, but we do that. This is done using what's called JMX beans. Does anybody know JMX beans? Raise your hand if you've heard that. Okay. They're just Java classes at the end of the day, but there's usually some sort of framework built to make it look command line-ish. We just call the JMX classes using plain old groovy objects, okay? But we can also apply the patch, which is done a couple of different ways too. The APIs change a lot. You can do it using a command line utility or also JMX. We usually use the command line utility. Does that make sense? So for regression testing, so you've seen kind of how we do this. We build something from source. We pull down a previous version. We may pull down multiple previous versions depending on how you've set up your configuration, how many different ways you want to test. So we have that, we deploy that series of binaries to a target server, and then we run our tests, and that's, I'm going to get to that. I actually have some code samples from Spock. Run our tests, patch it to the server, run the same set of tests again. These are not tests, you don't have to write each test. We just say, hey, it's this area of the catalog. So our regression testing framework goes and gets the output from all of that, runs it as a Spock spec, and produces the output. So that, and then once you've run it through twice, so this is one spec class, this is another spec class, and on the end is another spec class. So when you look at it, you've got a series of tests. A, did everything execute? We didn't get any failures, so you haven't changed it such that it won't even run. We know that this is going to probably be successful because it was tested before, its previous version. And then we have a new spec that goes through and does a series of comparisons. There's a lot of things we can test, and we turn those on. You can turn those on or off with configurations. Spock's very good about that. Test this, test this, test this, test this. Test the hash value of the results, or actually test the entire output of the results. Test what's called logical SQL. That's the generic SQL that the BI product generates. Has that changed? You can test all of this stuff. But at the end of the day, you're testing to try to ascertain whether anything has changed. If you think about this as a BI developer, you guys all take this for granted probably as real coders, but as a BI developer, they can just push their content and immediately know if they've changed anything dramatically. And not just on what they're working on, but an entire catalog of enterprise reports and dashboards. Okay? So that's the promise, and that's actually what works. So if you look at the baseline and revision, so those are the two tests to just run everything. I'm a SQL guy, so there might be better ways to do this. But for me, I just use the H2 database. So I want to go and get out of the catalog of reports all the reports that you've identified as regression tests. I pull everything I need to run them, and I'm putting them in an H2 database. It's just, you could probably do the same thing, putting it in a file and looping through it, putting it in memory, whatever. But I'm a SQL guy, so this made a lot of sense to me. So then Spock has the unroll. You guys all know about the unroll. So I'm able to use the where clause based on SQL. So this is the number of reports can change. You add a new report to the regression testing folder, it starts running. Okay, so no new class, no new spec, no anything. It's data-driven testing, I guess is the proper term for that. Makes sense? So the BI developer doesn't have to go write Java specs to test something. They just take a report, add it to a particular part of the product, and it just starts testing it. Okay? So does that make sense? Then we come to the compare spec. And again, I'm a SQL guy. So I just create a table that has the baseline and the revisions into it as a data set. And then I can easily, that makes sense, it's just basic SQL. And I can write, and this is just one test, but I could write any number of tests. Expect that the hash value of the results from one will be the same as the hash value of the results for the other. That's quicker than testing the entire results file, which might be monstrous depending on how much data is coming back from the report. But never had a problem actually running it, but it does take a while. It's doing it in Groovy at the end of the day. Does that make sense? So run it once, run it once with the current stuff. Actually, run it once with the previous stuff. Run it once with the current stuff. Compare the results. Write a series in Spock of specs to test if anything's changed. And it's very, very easy because Spock has this great unroll feature. How many people are using Spock and data-driven stuff in some way or shape or form? Yeah, it's really powerful. It doesn't have to be SQL. It can just be a collection. It can be a list. Anything that Groovy can iterate over can, and this might not be, I don't know if this will work. This needs to be up there, but I did that for ease of reading. So anything that's iterable in Groovy can feed into a Spock data-driven testing set. So that's how you're able to write specs once or twice, create a data set somehow. It can be a file, again, anything Groovy can handle, feed it through, it's all good, okay? So one of the things that's pretty special about how we do all this is, every build creates a distribution. So just like you guys, some of our customers we do snapshotting with because they get it. Some of our customers, that's just too much for them, all right? So a lot of our customers were building the same release, because nothing depends on it. It's in Maven for ease of use, but there's not any other library or development team that depends on it. So snapshot and versioning is not all that important. Versioning is important, obviously. And then when you do a deployment, you specify with a configuration in your build script, what version do I want to use for deployment? So when you're ready to go to a release branch, just update that, we automate that, but update your promote configuration to be whatever the new release is. Then when you go out on that server, you don't have to check anything out. We like to use continuous integration servers for deployments, but a lot of our customers' admin teams, it's like, what is that? Give me a command line. And so they have that. It's a Gradle. The build script already has the version to promote, pulls it down from Maven, unzips it, uses all the different APIs to push everything. And because we have this regression testing framework, it immediately becomes a smoke testing framework. Okay? This same set of tests that you've run over and over and over again during the regression testing process and the development process can become your smoke testing. We don't need separate integration tests and all of that. We just deploy the new content, pull down the content that was previously there from Maven, run all our tests, and we also create, you saw where we create those patch files, right? We create what's called unpatch files or rollback patch files. So if anything fails in that smoke testing process, we just roll back, right? That's so far above anything that our customers have ever had or seen, and it's probably fairly common to a lot of folks in here for what you do. So the next final, I'll say, piece I want to talk about is workstations. Okay, so again, this is an enterprise product that doesn't really, there's no IDE, right? So how, most of our customers are all sharing time on a dev server to do this stuff. So not only do we want to automate the testing and delivery process, but we want to automate the development process. We wanted to do multi-user development, not just sequential development, which is what they do, and they think that's multi-user development. I'll develop, then you develop, right? Crazy, right? So we wanted to enable multi-user development in the process. So this is not going to seem all that interesting to you guys, but we create these workstations. OBIEE has what's called a simple install. Has all the same functionality, but fewer containers, fewer moving parts, but you can still develop all the pieces on it. So usually using virtualization, we have a lot of hosted customers. We do this in Amazon. They have a full stack of the product running on a workstation. So how do you get content in and out? Gradle, right? So our plugin handles this on the workstation for them too. So it doesn't just handle the downstream build process. The developers are actually working with Gradle on a daily basis. They just don't really know it, and I'll tell you how we do that. So Checkmate has all the APIs to enable pulling content into their workstations, which is just a mini build and deployment, right? We also have all of the utilities to kind of do a reverse build, right? So imagine being able to take a jar and turning it into software. Well, we can do that with this product. We can take the artifacts and reverse engineer them. There's utilities for that. So we actually handle, when they've made their changes in the server, taking that content and putting it back into Git, okay? Just pull down the binary, convert it to XML, copy. Gradle's great at all of this, right? Calling an API, copying something, usually sync. So the developers are actually interacting with Gradle, they just don't even realize it. So the back end you pretty much get, right? The developers are everything else downstream is, besides our sort of complicated regression testing process, is not anything different than you guys are probably used to, you folks are used to. So how do we do, how do we give a developer CI-like capabilities? You guys use IDEs where you can just call Gradle, right? And then call your regression tests. There's no IDE for this. There's a bunch of proprietary development tools, most of them web-based, okay? So how do we do it? We built the Griffin app, okay? Using the Gradle tooling API. So whereas your IDEs use the tooling, the Gradle tooling API, it's really a very, very simple set of Java objects and classes. It's very, very simple. Anybody ever written Griffin? It's just like Grails. It uses the same sort of convention, over configure, whatever. Right? It's got scaffolding, builds you, auto builds you a bunch of things, but the end state is not a web application. It's a full-fledged client. Okay, so it's not pretty. This is our release 1, but we have big plans for this. So we envision giving the customer everything they need to know. I don't think we're going to try to replace a Git client, although that's what a lot of them want. Sorry about that. So we're not going to do that, but basically we just have a menu of Gradle tasks at this point. Okay? Some of them require passwords. If you're going to restart services, if you're going to deploy things to a server that require security, we don't want to necessarily bake that into environment variables or properties files, which you might do on the back end. So we just ask the user for them, and they pass, and Gradle tooling API passes that as properties to our plugin. Okay, so we have big hopes for this. So this takes the place of that IDE integration that you all rely on so much as developers. Our developers don't have that. So I think I have 10 minutes. I took some slides out to make sure I got in under 45. Now I wish I hadn't. But I'm just happy to take some questions if anybody has any. I know it's a little bit outside your usual sort of purview.
So what's the difference in time for the customers? I mean, compared to the old way?
It's really difficult to, you guys are so used to comparing one automated process to another in time, right? It's so difficult because everything's manual for most of them. So all I can say is that what really happened most is that they just waited to release for long periods of time. So that's value in and of itself, right? Because they're so scared because there's been no testing from this point to this point. So they send it to QA, which would manually run through, I'm not kidding, manually run through reports and side-by-side screens, and that most of our customers who are using our products still do that, but they're just looking for look and feel. They don't even look at the numbers anymore. They know we've automatically tested the numbers. So for some sort of a swag, it's orders of magnitude. It's not just how much time, it's our culture is now different. It is blossoming CI, which is take that to an organization that's never even thought of that or done that. The rewards are time, are human error eliminated, right? I mean, a lot of times these build processes where we create these patch files, because a lot of those binaries have system dependent, environment dependent information in them. It's awful that they do, but they do. They would open these up as part of the deployment process and change them. So because we create patch files that are all come from the same environment, the only thing that's in them is development differences. So the fact that we can use those patch files, and we also create the rollback patch files to deploy to environments, not only make the deployment dead simple, but also it enables our testing, right? So we upload the old version of the content, we apply the patch so that we can test, and by the way, we've just tested the deployment, right? So it's difficult to quantify because it's like, here's the number we have now, we don't know because it was so fraught with error, really. I hope that answers it. It's big.
Yeah, I was expecting.
Big, yeah. Any other questions? Yeah. Hey, Max.
How do you handle cases where the test results are supposed to change?
Yeah, that's a good one. So there's a Jenkins plugin for that, and Bamboo. A lot of our customers use Bamboo because a lot of our customers use Jira, and it's a natural fit. Bamboo has the quarantine feature in the CI server. There's a Jenkins plugin for it as well. But you could go, a regression test for us is not necessarily a bad thing or a failure. it is something that needs your attention. And so the first thing is that you probably may not have gotten it from that union statement, but we do only test. So we run all the tests that they've identified in the catalog as a regression test. We run all the tests that were identified previously in the previous version, and we only take the stuff that matches. So we only compare, if you've added a report, it's not going to start getting compared to until the next release. So we only compare stuff that's in both places. But you may have changed ETL, you may have changed the report, you may have enhanced it, fixed it. So we just go through the process. If we're using Bamboo or Jenkins, we do that in the CI server, and we just quarantine it. What do you get on the client side? They just have to know, and it's certainly something that we're thinking about. How do we get that same sort of quarantine functionality that we rely on the CI server to give us into the client? We haven't fixed it yet. Anything else? So I really am surprised I got this many people in this talk. I'm really happy at this conference. So thanks so much for coming and listening to me. I really appreciate it.